You may remember my presenting video of my, at that time, new table saw, and my review on it, or all my first impressions on it, were rather positive, because I really liked everything about it. Until now, because there is an issue. And the problem maker now is this here. And this is a flip-up 90-degree positive stop for this fence. It should make sure that it's always square to the blade every time you install this fence. And when I got the saw, I used the 5-cut method to set it to exactly square. And since then, I just trusted that. And every time I installed it then since, I made sure that it would contact the stop in the T-slot, and then this stop. And then tighten it down while holding these two stops. So yeah, in theory it should have always been square. But surprise, it wasn't. And because of that, I never really checked it that often for being square, because I was just expecting it to be square. And that's why it took me so long to notice it. So then the first time I checked it and it was out of square, I just thought I didn't set it up correctly. But as it then happened more and more often, I knew this couldn't be my fault. It has to be something else. And so I finally took a closer look at what's going on. Now I really like the idea of this because it's a great concept. But the way it's built, it's not good. And I'm saying it like that because if I would say what I really think right now, I would have to beep over it. Oh yeah, and by the way, I really hope Felder to see this video, because this is a rather serious issue with a 3,500 euro saw. And I really doubt that I'm the first one who notices that. But now let me show you where the problem is. So as this piece flips up, it hits this adjustable cam lever, and with it you can fine tune it. And well, there's the first problem. Again, being able to micro adjust it with the cam lever is a great idea. But now look what happens if I move it. It moves the screw as well. And as I move it, it tightens the screw and it becomes harder and harder to move the cam, and then it becomes impossible to move the cam. Now let's say I would have to move it a little bit further, but it's just too tight to do it by hand. Then I have to loosen the screw. And the moment I do that, the whole thing moves and I just lost my last setting and I can start over. Now if I would have to mess with that setup only once, then it would be okay. But that was not the main issue. Now the screw of the flipper piece also moves with the rotation. But its screw doesn't tighten or loosen because it has a lock nut on the back. But this screw in the back plate has play. And that's the issue. And the problem with this play is that the pivot point of the flip piece is always at a different position, which then means that the reference surface for the fence is always at a different position. So sometimes the fence is set square and sometimes not. And if I turn the screw, you can really see it. And that's just not reliable. Now to be fair, when I said it was out of square, it was like 0.5 millimeter over a 40 to 50 millimeter distance. That's not too much, but for a saw in this price range, it's too much. And it's also not accurate enough for me. Alright, now you know the problem in full detail, and I'm going to make a new one of these. Same concept, better design. Oh. Now if you take a really close look, you can actually see that the threads that rubbed inside the hole are a little bit worn down, so it must have been getting worse over time. But putting a screw which threads aren't really that precise into just a hole wasn't really a good idea to begin with. Oh my god, so much play, that just can't work. The material for the new pieces will be 5mm aluminum. Now steel would be nice, but I don't have some on hand, and I also don't think it needs to be out of steel, because the sliding table is out of aluminum, the fence is out of aluminum. Why would these pieces have to be stronger? These original pieces maybe because they had to do with more friction, but if you see what I'm doing, then you will see that aluminum is enough. Also, this is more than the average aluminum, it's some aluminum alloy, so yeah, that's the material. Now we'll also find out if my CNC machine can cut aluminum.
Now before anyone has the idea of telling me I need to use lubrication for this, let me tell you that this end mill is normally used for milling hard steel with a tensile strength up to 1800 Newton per square millimeter. So milling aluminum is a really easy task for it, and this aluminum alloy also doesn't seem to smear or clog the cutting edges, but it creates nice shavings. Overall this milling worked great, the piece came out nice and clean and the bit as sharp as it was before.
Nice.
With the pieces still attached to the tabs, I reamed the holes to 6 mm.
These new parts will pivot on a piece of brass rod, and this one has a little bit more than 6 mm. But as these holes are reamed, this won't fit. And surprise, it doesn't. So to make it fit, I'll sand it down carefully on the lathe.
Then cutting some threads, and cool squeaking noise with brass. And then cutting it off with a hacksaw, which has to be one of the nicest things about metalworking. Brass cuts so easily and you barely have to apply any pressure. The cuttings just fly out of the curve.
Now that these are cut, making sure that they still fit their holes. And they do, so now I can cut these pieces free.
The leftover tabs are removed with a file.
The old parts and the new parts. Right, now I can start putting it together. This is the shaft for the adjusting cam, and it threads into the old hole and then gets secured from behind with a lock nut. Oh, this might be a problem. Well, small plan changes. I won't use the lock nuts from behind to secure these shafts because there's just no way I could hold this tight enough to thread a lock nut on without damaging it. So I will use a regular nut instead and therefore then Loctite. Well, for the second shaft there are no threads, so here I instead just thread a nut on the shaft, put it through the hole and then lock the nuts together, and this will also keep them in place. Now I can put it back in the slot, and as you can see the nut conveniently fits in the slot. Then I can tighten the set screw and everything is in place. So now for the new pieces I'll use a brass washer, then the new flipper piece, another brass washer, and this should minimize friction so it will be easy to flip it up and down. For the adjustment cam I'll use a regular washer, then the cam and another washer, because here I would rather have more friction because I won't use this a lot, and once it's set up it should stay where it is, so more friction is better here. To secure the pieces here I need to cut some more threads on this end for some more nuts. To hold it while not damaging it, I lock two nuts together on the existing threads, and like so I can put it in the vise. Now as lock nuts aren't that big, I can also cut this a little bit shorter. Now that's the final installation, I also put some Loctite in the threads. I also think it's worth mentioning that it's very easy to install now. In addition to brass, I also add some lubrication to the flipper piece. And I can also easily adjust how tight I want this to be. That's a little bit too much. Ah, that's really nice. The only thing that it doesn't have now anymore is the low profile, but why? There's the handle, there's an extension table, why would it need to be low profile? Everything left to do is to set up the fence square again, and now, hopefully for the last time. Now lining the square with two teeth, and let's see where we are. Right now there's still a gap. and I need to bring it forward a little bit. Alright, this is as square as I'm gonna get it with this method by eye. So now it's time for the 5-cut test.
With the 5-cut test, you take a piece of plywood, for example, and make a cut. Then you rotate the fresh cut surface to the fence and make another cut. Obviously, you do that 5 times. And by doing this, you add up the error in the fence, if there is one. And on the 5th cut, you then want to cut off a strip and keep that.
If the fence was perfectly square, then the strip would have the same width in the front and the back. And I can tell by eye that that's not the case. So let's see by how much. 5.83 in the front, 7.12 in the back. So that tells me that the fence is off by about 1.3 millimeters, but as I cut 5 times, that's over a 1.8 meter distance. And that's already quite good. But we can do better. So as the strip was wider in the back than in the front, the fence is off, if I exaggerate a little bit, like so. And that means that I have to bring the fence back a little bit. Yeah, this much. This is the strip from the 5th test, and it has 4.44 in the front and 4.45 in the back. That means that it's off by 1/100th of a millimeter over a, well, the square got smaller, but still over a more than 1.5 meter distance. 1/100th off. I can live with that. Time will tell if it keeps that accuracy. So yeah, now it works and should be reliable. And I say it again, I really hope to reach Felder with this because I would really like to know what they have to say about that. I probably already know the answer, that it has to fit a certain budget and it's too expensive to make it better, as this is mostly the answer to these problems. And I know my solution is totally overkill and totally unrealistic to mass produce, especially with reaming. They'd probably also tell me if I want that accuracy I would have to step up to the Felder machines and not their hammer ones. The saw already is expensive. For a price of more than 3.5 grand for this saw, I should not be the one who has to deal with that. And I assume that everybody who's willing to pay this much for a table saw, and this is actually the smallest of their models, is also willing to pay 50 or 100 euro more that would be required to make this essential part properly.
And I know that there is a big extension table for this saw, which has a really nice fence system. But you need a lot more space for it, and it also costs extra, so it doesn't really have anything to do with this problem.
Now I think I also have to mention that I don't hate this saw of Felder. I choose this for good reasons, and I love pretty much everything about it, except for this, and that's why I replaced it. And if I had to buy a new saw now, I would probably choose the same one again. And then throw this piece out and replace it. And if you have the same saw with the same problem and want to fix it, I put the template for these parts in the description, and if you also have access to a CNC, I also put the SVG files of these parts in the description, and you can download them there for free.